Okay, so today we're going to be doing the Codility MaxCounters problem from Counting Elements Lesson 4 of Codility. So here's the question. You are given n counters initially set to 0 and you have two possible operations on them. The first operation is increase x. The counter x is increased by 1. The second operation is max counter. All counters are set to the maximum value of any counter. A non-empty array A of m integers is given. This array represents consecutive operations. If A of k is equal to x, such that 1 is less than x is less than n, then operation k is increased x. If A of k is equal to n plus 1, then operation k is max counter. For example, given integer n is equal to 5 and array A such that A of 0 is equal to 3, A of 1 is equal to 4, A of 2 is equal to 4, A of 3 is equal to 6, A of 4 is equal to 1, A of 5 is equal to 4, A of 6 is equal to 4. The values of the counters after each consecutive operation will be as follows. The goal is to calculate the value of every counter after all operations. Write a function that given an integer n and a non-empty array A consisting of m integers returns a sequence of integers representing the values of the counters. The results array should be returned as an array of integers. For example, given this array, the function should return 3, 2, 2, 4, 2, as explained above. Write an efficient algorithm for the following assumptions. N and m are integers within the range of 1 to 100,000, and each element of array A is an integer within the range of 1 to n plus 1. Alright, let's do it. Okay, so let's define again, to recap, what n and a are. So n is the number of counters, right? A is the consecutive operations to be performed on the counter. Okay, so it basically told us the steps of everything that's going to happen already. It's already diagrammed out for us. So let's see how we're going to solve it. 1. If. It's basically a simple incrementation problem. I don't even think I have to write out the steps because it's so simple. So we're going to have two functions. One will be max set to max, right? And the condition under this, when this will be run, is if we're incrementing value that is out of the range of the array. So we would need, in order to use set to max, we would have to track the max counter value. Currently starting off would be at 0. And we would have the increment 1 functionality. So this would get an array and it would return A, and within this array we set everything to 1. So basically we can say A is equal to new Should we declare a new array, or do you want to do it in a loop? Let's do it in a loop. For let I is equal to 0, I is less than a dot length, I plus plus. In a real interview, you would actually write out the steps, diagram it and stuff, but in this case, I'm not going to even bother. because it's so straightforward. And we basically set the counter value to max counter value, right? The next operation we will have is increment by 1, right? And then we don't even need a function for that. So we're gonna iterate through all our operations within our array. We would also need a counter of array of counters, so we have to define our counter. Array of n we're going to find out how to define the default value of all the values in the counter. Okay. One way to do it within a loop. I think that there is a built-in way, despite what they're saying. Fill. There we go. So we should use fill. We'll fill it with zeros. So we have an array of n values, and it's going to be filled with 0. And while I is less than a dot length, let's make this r so we know it's a different value. Okay. So what's happening here is we are we're performing the operations on the counter. I++. So if I is greater than n, I plus 1 is greater than n, what we're going to do is set to max, and we're going to pass in our counter. Right? That is one condition that would happen. The next is and then in that case we would continue, because we don't need the actual loop to continue. It goes on to the next operation, right? However, if I isn't greater than n, what we're going to do is set a counters of I++, so we're incrementing it by 1, right? Okay. And then at the end, we will return the counter. So now let's backtrack and see if we got everything. So we have a set to max if I is greater than n, and then otherwise we will increment the value of I based on a of I. So my mistake. No, we're incrementing through the operations. So we have a position counter plus is equal to a of I. So counter pos is greater than n, set to max. Otherwise, for cost minus 1 plus plus. Okay, that should do it. Let's see. It said wrong answer. So we got 10020. So that is the problem with not mapping out the steps. So let's see what happened. In this case, we should use console.log. Oh, we have another problem. See, we forgot to track the max counter value. Max counter value. So this is another condition. If counter, no. If counter of counter pos minus 1 is greater than max counter value is equal to this. So each time we increment, we check to make sure the value, if the value is larger, and if it is, we store it. Okay, that looks good. We got the value we expected. Let's test it out. Okay, so we got 100% on correctness, but the performance can be improved. So in part 2, we will work on finding a solution to solve this problem in less time.